Well, Peter here. Going to have another discussion today about the Class E transmitter and the how to build it. Some general thoughts on building it. So we're focusing on the RF deck right now. On another video, we'll discuss the modulator also, possibly the VFO there, which is on top. But today we're going to talk about the RF deck and some of the things that it takes, some of the requirements that it takes to build one of these here transmitters. I built this transmitter, as I mentioned in the first video, probably, oh boy, at least probably 10 years ago, I think. This is from the design of Steve WA1QIX. He's the genius behind it. I just built it, really. So I built it from a schematic. In fact, you can see it here. Here's the this is look at the date there. See, 2006. So that was when I printed this this schematic of the RF deck. So you can see it's a little dated, but really nothing has really changed. So if we, you can see here, when I began the transmitter, when I began to build the transmitter, the first thing I picked up was a heatsink, which is in the back here, in the very back of it. That's the heatsink right there. I think it was a 7-inch tall heatsink. In fact, the fins actually go the wrong way. They really should go up and down. The fins should vertically go up and down, or should be aligned vertically. These are aligned horizontally. So I added a small fan in the back, very quiet fan, when I went to the electronics store, which I believe was HR Electronics in Portland, Maine. I said, "Give me your quietest fan you have." And they said, "Oh, this one does this and that." And I said, "Great." And I think it wasn't very expensive, maybe $10 or something. So the second thing I picked up was, well, that then determined what I was going to have for a size for a cabinet. The second thing I picked up was the front panel. I picked that up from the same place. In fact, Peter, the guy who owned the store, had that. I thought it was like what is that? Like a 5 or 6 RU panel. He had one hanging around. In fact, he had a couple of them. So I then determined what the size of the cabinet was. So then I designed the rest of it in AutoCAD and went to a sheet metal shop and ordered the. I believe I built it with 1/8-inch aluminum plate. I don't remember what series it was. Something they had on hand. And basically, it is built with aluminum angle iron, aluminum angle, not angle iron, but aluminum angle. And we drilled and tapped the angle. Let's see if we can zoom in a little bit on that. No, we're not going to zoom in. I thought we could, but we're not. So anyway, so the aluminum angle is right here. And I believe it was 832 stainless screws. So we drilled and tapped all the angle and got it put it all together. Bob W1IF helped me with it. In fact, we actually built 2 of these transmitters, one for him, one for me. And it took me about a year, I think, to build the whole project. So pretty sizable project. If you are a builder, experienced builder, you shouldn't have any trouble building this transmitter. You want to start with the RF deck too, as opposed to the modulator or maybe the VFO. Start with the RF deck, and it's the probably the most challenging part. The modulator too has got can be tricky, but this has probably got the most work to it. There's a lot of drilling and tapping in the heatsink, and so forth, so on. So, looking at the metering here, The lower 2 meters are for each phase. There's two banks of chips in here, and so I think in this case we used a total of 12 FETs, six per side. So each the two on the bottom represent those two phases. Though this ammeter here is the total current. I limited the total current to 10 amps, and therefore limited the RF output power to about half the half power. It was capable of doing maybe a little under 600 watts of RF power, but I decided to limit it to about 250 to 300 watts. It runs about 300 watts on 160 meters, and it runs at about 250 watts on 75 meters. You can see here the big coil you'll see on top there is which is this one, is the 160 coil. And we'll zoom in here in a few seconds, and we'll show a little bit more of the innards of the RF. Okay, taking a look at the RF deck. Some of the internal components, as I mentioned earlier. There's the 160 coil. Just underneath there, you can kind of really barely see it, is the 75 meter coil, which is about half the size. This device here is the loading capacitor, and that actually is disconnected now. I'm not using it right now. That was connected to a doorknob, but we ended up not using that any further. This area here is where the RF electronics are located, and then this area over here is for the metering, and also for the power supply for the driver transistors. So, or the driver FETs, maybe we should call them. So, the FET that we use in these Class E transmitters, this is again Steve's design. This is the FQA11N90. I believe they're not making this chip anymore. It's now, I think, the FQA11N90C is in Charlie. So these FETs are used in they're MOSFETs, and they're used in switch mode power supplies. They're very expensive. They're only like $3 or less than $3, I think. So I still have a stock of these things. So that's the story in that. And also the case of the chip is not grounded. That is not at the source, connected to the source. It's connected to the drain. So you do need to put in one of these pads, and also don't forget to use some thermal compound on it, some heatsink compound on it. So looking at things over here, these are relays here for switching 160 back 160 to 75. They switch in. See if I can get in a little better there. There we go. See if we can switch in, and we switch in some doorknob capacitors in there. Doorknobs are probably not the best choice. Today there are some, due to technology, there are some better choices. The ATC ceramic, I believe the ceramic capacitors are very good, very low inductance, and would be a better choice than the doorknobs. Like you can see, these big Russian doorknobs that I ordered way back in those days. So, also, if you can look here, you can see there's a copper bus bar right here. That's what I use for. Let's make sure we tune it a little bit better there. That's what we use for the ground bus bars and for bus bars in general. But it works great with the ground bus bars. So essentially, I ran it around the heat sink with a lot of screws, because you want good contact with the heat sink, good mechanical and electrical contact with the heat sink, and that becomes your ground for all your connections. So that works out really, really well. So I highly recommend that. I picked up the copper pieces from a roofing contractor who worked with copper, and he actually had a lot of scrap, and he actually cut me some pieces from his shop that actually lasted for quite a while. I used them on all kinds of projects, not just these Class E transmitters. So, and if you can see it, there's a bus bar there. I think that's the drain bus bar, and there's one little one in back, which was what the drivers are connected to. So, as I mentioned, there's 6 sets, the 6 FETs per side. There's the 2 sides there. So this is the I mentioned here, this is the loading capacitor here. Let's tilt that down a little bit. Loading capacitor there. You can probably not see it particularly well, but that's the tuning capacitor there. And in this case, I used a vacuum variable. I think it was around 12 kV, which was a little overkill, but I decided I wanted 12 kV just in case I wanted to run it at full power. So this top capacitor is the auxiliary tuning capacitor that is used for tuning the 160 band. So, and that's pretty much the story on manufacturing or certainly making the RF deck here, the Class E RF deck. Also, here's a coil here that I made. I recommend making the coils of solid copper wire, versus soft copper tubing. It's not going to crimp. It's not as the trouble with the copper tubing is really easy to crimp them. And also, I don't know this for sure, but I believe that the solid conductor will not get as warm as the just for the fact that there's just less surface, not surface area. There's just less material with the soft copper tubing versus the solid electrical, which you can pick up at the Home Depots and that kind of a thing. So you can wind them on PVC pipe. I think I wound this on a 2-inch PVC pipe. So there you go. That is for those that are interested. This is a great project. I enjoyed it very much. It certainly is a challenging one. And oh yes, I want to show one more thing to you. These are the Type 43 ferrite cores that I used in these transmitters. If you look over here, you can see there's actually I think there's 8 per side. So there's 4 here, 4 here, and of course there's another 8 in back. And I've got them all taped together with electrical tape. So I think these I forget the number on this. I believe these Type 43s, I believe that is 1 inch long, and I think it's 1 inch in diameter. OD, maybe, I think the ID maybe 3/4 of an inch. So I use these cores on all kinds of projects. Like I built some other projects that involve these things. There's they can handle some considerable currents, and they're just very useful to build with. So there you go. That is the story on working with the RF deck. highly recommend building it. I think it's a great project, and so forth, so on. So I hope you enjoyed it, and I didn't put you to sleep because I could have. So